Hello, this is my case for C++ and Unreal Engine. It is on the idea of waste where you want to do something and it's how many steps to do it and what you can reduce. So right here is a widget for our buffs in the game. We use the gameplay ability system. It shows an icon and the time remaining. The issue was we were just getting the remaining duration and setting the text, which was fine until we found out you can have multiple stacks of buffs, and it did not handle it correctly. So our first idea for a implementation was to get the total duration, get the stack count, take away 1, multiply it by the total duration, and then add it to the remaining duration. So if it was 10 seconds, it would count down 10 to 0. But if you have anything in the stack, it would add that to the 10 to make 20, and it would count down from 20. With the old way, when the stack refreshed, the number would reset, and we just wanted to show the entire number. Now, the first issue that I had with this was I didn't like how many nodes there were. This is a lot. We could probably condense it to 1. But each blueprint node does a bit of stuff. For example, this is the custom one I made. This is the custom blueprint callable event I made in C++. But we can get a general idea. We have these 2 lines here, which are parsing the parameters for the function. We have this here, which increments the stack so that we can move through our blueprints quicker. And then we have native and end, which are just an optional timer, I think. Unreal keeps track of these things for debug and development builds. And then this is the call we want to get the number. So this does a few things, and it does a few things more than what we would want. We just want to get the number. So I decided to try to cut down on how many times we call from blueprints to C++, and I made my own function. Get time remaining including stacks. So it just does all the work for us. The thing that I noticed when implementing this event was that the ability system, every call, so get gameplay effect remaining duration to get the remaining duration, would get the owning ability system component, make sure it's valid, get the gameplay effect, and then check if there's a world to get the time remaining. The effect total duration up here would get the ability system component, check to make sure it's valid, and get the gameplay effect. And it would do the same with the stack up here. Get the ability system component, get current stack and count. So that's also a lot of checking when we only need to do it once. So my implementation did it all in one bit, because instead of checking the ability system component each time, we only need to do it once. It's going to be valid. Instead of getting the gameplay effect every time, we do it once, so it's valid. And then we have a world in this example to get the time remaining, and I add it together. This is good. This does the exact same thing here as it did in our blueprint example, but the blueprint example had those extra if checks to make sure the ability system, it could get an ability system component, and it had a few other of the processing of blueprints. And this is a quite minor example, but it does show that when you call to blueprints, it does some processing, and the functions that exist may also do some processing. And this is just to be a case to use C++ in a project. You don't have to use it everywhere, and I did not profile a before or after, but this was a good example as it showed, a bug a Blueprint implementation and a C++ implementation, and how there's a little more waste. I hope I was able to show that there was a little more waste in the Blueprint example to process the Blueprint events, and that the functions do some extra comparisons. In the grand scheme of things, this might not have been a lot to save on the CPU, but stuff like this would probably add up over time. So, pick and choose your battles of when to use C++. And it was just a Blueprint function library as well. It's not like I made a base class of a user widget compared to an actor. No, it could be just a general function that does a bit less processing. Back to my main point, this version of the code calls out to Blueprint. It does the processing once to get the object, increment the stack counter, and get a result. And the result itself does all the comparisons in one function, compared to doing this 3 times for each 1, 2, 3, and then also at the very least making sure that the ability system component is valid, as well as the other one does a second gameplay effect valid. Thank you for coming to my TED Talk.